where they, and there, due to environmental pressure and change, these species, they change very, very rapidly over a short time, a few thousand years or 100,000 years, which is a very brief time in geological terms. So then they, under these circumstances, then they change suddenly. And then after number, maybe 100,000 years like that, the isolation is broken, and suddenly this new species, then they spread over a bigger area. That's more or less their idea.
But if that were to make sense, then there would be some kind of specific need for them to evolve so quickly.
They would say because the environment they live in are so different from what they were living in before, and so extreme. So therefore they are suddenly forced to, under pressure forces them to change in a different direction. No, actually, I mean, your critique is right. It's, that is their theory, but as they had to argue for the theory, they were actually they lacked a mechanism that can really cause that great change. But and also, I mean, no, this theory does explain why the fossil record is so uneven. It's not gradual. It's actually so unchanging, and then suddenly there are changes just similar appearing out. It does explain it, but actually it itself, you might say, it explains one problem but creates 10 more problems, because I normally consider this kind of evolution through inbreeding. Do you know what inbreeding is?
Is that like when two different species they have?
No. In our, is that Norwegian?
Yeah.
In our. It
Really
means that, for example, you have only one couple of chicken, for example, one male and one female chicken, and they, mate, and they could get some eggs and some small chicken. And then these small chicken, they mate amongst each other. They're brothers and sisters, and they mate. And then these next generations, which are brothers and sisters and cousins, they mate, but they're all very related. And what happens when inbreeding takes place? Those new species arise.
Not really, but as far as I've heard, you get all these misshaped bodily features.
Simply the species become extremely weakened, and all kinds of diseases come up because the genetic material is actually strengthened by, and that's also why, for example, it's actually forbidden to not marry your sister, or not even your cousin. You're not allowed to marry your cousin, and because it's dangerous. The offspring, the children, can get all kinds of hereditary diseases, which is not possible when non-related individuals mate. Actually, no, inbreeding weakens species, weakens organisms, cause all kinds of diseases. It's actually seen in royal families. They're somewhat inbred because there are fewer and fewer of these royalties. And actually, it turns out like they end up marrying their cousins and like that, and doing all kinds of, like, I know the English royalty, they are quite inbred actually. So inbreeding is not a very promising process for creating new, lively, more fit to survive species actually. And so that's one problem with this punctuated breeding theory. And in any case, it also has a problem that even you cannot change species if it happens by chance mutations in a few individuals or like that. These great mutations don't happen more frequent just because the species is under pressure. And it's has, in all law, it's mainly an attempt to explain away an imperfect geological record, perfect from the point of view of evolution. But the theory itself is, has many problems. And if they accept it today, it was very popular and highly advertised in the 70s and 80s, but somehow or another, it's not even so popular anymore. But that doesn't change. The problem with the fossil record is still there as much as ever.
So it's basically just Maya engaging them in their service.
Yeah, keep them busy. So they can go and get their paycheck every month. And and what's interesting is also that okay, it might be punctual equilibrium, but it just also happens that this unchanging fossil record is completely what you expect if species were created separately. And you have to remember, actually, this is actually what Darwin is arguing against. Darwin is arguing against the idea that species are created separately, and also he's arguing that everything happened naturally. So this is what evolution is arguing against. But the fossil record is actually completely consistent with the idea that species were created separately. This is what we would expect to find if species are created separately, that you have species appearing suddenly and don't change over time as long as you find them. This is so it's consistent with that actually. And punctual equilibrium it's mainly an ad hoc theory actually, if you really look at it. Ad hoc. It's Latin, and it's a theory. You have a very simple theory, and that should be the beauty of a true scientific theory. It should actually be a simple theory that by application can explain a lot of very complex phenomena. It looks very complex, the whole thing, but actually as you with this theory, few basic principles, the next turns down, no, it's actually very simple. This is what Newton did with his laws of movement. He was actually able to explain a lot of complex things with this with three simple laws. But ad hoc theories actually goes the other way around. You have a theory, but all kinds of other observations and phenomena and so on contradict this theory. So instead of discarding or rejecting the theory, then you make a theory to explain why the theory doesn't match with what you observe. And this is ad hoc theory. That was in, for example, when they were working with geocentric theory. And I'm not going to get into whole discussions of that, but it used to be that they thought that the Earth was the center of the solar system, but they had many problems with observations of the movements of the planets. They were, and in order to save that theory, they had to add to the simple fact that planets were spinning around the Earth. They also had to add that because sometimes they spin around the Earth, but they also sometimes just make spins like that in space. They call them hypercycles. And so they had to introduce hypercycles just to save the theory, which they claim was solved when the sun was put in the center. So that's at least as an example of a ad hoc theories. And so this punctual equilibrium theory is basically an ad hoc theory to save the theory of evolution from the fossil record, or the actual pattern found in the fossil record. And then let's look at this particular striking example of No, okay. Here's just one example of what they find. This is from 2009. This is a research where paleontologists found something like 2,000 mega fossils. You see they're quite big, these fossils. You see this scientist, he's holding one big slab of rock with a print of a big leaf. So these were plant fossils found in Colombia, the rainforest, tropical rainforest in Colombia, 58 million years old fossils. And what's interesting is that these fossils, they're not different from fossils found today in the same rainforest. Same kind of plants. It says here that these new, do you have that here? Maybe not. No. But it says that these new plant fossils show us that the forest at Titanoboa's time, 58 million years ago, in many ways looked like the forest of today. The forest of the past in northern Colombia had similar families of plants as we see in today's ecosystem. The foundation for the new tropical rainforest was there for already 58 million years ago. Basically saying they haven't changed over these 58 million years ago. So that's just one example. It's standard, it's typical. So then we go to a particularly striking example of sudden appearance of life forms. That is the Cambrian explosion. Cambrian was the geological period which started 550 million years ago and lasted for something like 50 million years. And this period is when multicellular organisms appear. Before that, there are only single-celled organisms, with a few exceptions. That was not mentioned in the movie we just saw. They said there was only single-celled organisms before that. It's not completely true. There are a few multicellular organisms found in the Precambrian period, just maybe 100 to 200 million years before the Cambrian. And but these organisms found in the period before, actually, they're not related to the organisms that suddenly appear in the Cambrian. That's because you'll hear that argument brought up on some occasions. They will give as the standard example is fossils found in Australia called the Ediacara fossils, and they are like, I think they used to say that 700 million years ago, but recently they adjusted them and made them, they're apparently younger, 600 million years ago, they're just before the Cambrian. And so some will claim these were the ancestors to the Cambrian fossils, Cambrian species, but actually they're not related. If you ask the actual experts, they say they're not related. They're not even sure if they're plants or animals or whatever they are. They are some very peculiar shapes, kind of fossils, and they're not sure what they are, and they're not at all related to the Cambrian fossils. They're not able to establish that. So it is true that before the Cambrian, you have single cellular organisms basically for actually 3 billion years on the Earth's history. And then suddenly, with no ancestors, no intermediate forms leading up to that, suddenly you have the most complex living organisms, as complex as we find living organisms today, with all kinds of complex body forms like hearts and like the same body parts we have. The example we saw in in the film was eyes, the eyes of trilobites. And the eyes of trilobites are as the same eyes found in insects, compound eyes, very, very advanced, very complex eyes, and they're just there. There are no more simple eyes you can follow in the fossil record leading up to the eyes of the trilobites. They're just there, and that's so that's a. And what's even more striking is that not only do we find in the Cambrium the same variety we have today. Actually, the variety is greater. It's much greater than found nowadays. It's if you imagine the tree that Darwin proposed for his evolution, then you have this, one species, branching out and forming a tree. So actually, the greatest variety is at the top, meaning it's present, and the least variety is in the beginning. But that's is not what actually we find in the fossil record. We find for 3 billion years only single-celled organisms, and then suddenly in the Cambrium you find a much greater variety of organisms than we have today. And then no new variety arises after the Cambrium. It's only after that it's only variations over the same varieties, over the same themes that were found that were in the Cambrium. No new, they're called phyla. Organisms are classified in a hierarchical order. You have as a top, you have the animal kingdom and the plant kingdom, and in the other end you have the species. There are species, then there are genera, then there are families, orders, classes, phylums, and kingdoms. You know the system? You can follow?
A
little bit. Like humans, we belong to the species Homo. We are the species Sapiens, and we are the genera Homo, as far as I know, and belong to the family Hominidae. I might be not completely right. And then we are in the primates order. We belong to the primates pedigree. Primates. We're in the family of primates. Anyway, I'm not strong on this. They're primates, and then they're mammals.
Primates are like monkeys and...
Mammals, pedigree.
That's mammals.
Yeah, that's mammals. Yeah, pedigree.
The
Primates are the monkey species.
Yeah.
And then we have the vertebrates. Do you know?
Oh.
That's a class. And then is it the order?
I don't think you mentioned the order.
Yeah. Anyway, I'm not precise. I'm not exact in this. But you get the idea. This is how they are classified. Organisms are classified generally, and just after kingdom, we have animal kingdom, plant kingdom. Then each kingdom is divided into different phylums or phyla, however you words. And it's actually all the phyla that appear. They all appear in the Cambrium, and after that, no more new phyla appear after that. Which is all of it is completely against Darwin's idea about how things they diversify more and more as time goes on. So it turns the tree completely upside down. That's actually that's really the mystery of the Cambrium. And again, they have no clear explanation for that. Some will deny that it is real. They'll say that the fossils, or they were actually living these intermediate forms, but they didn't leave fossils, so all the fossils have been destroyed ever since from the Precambrian, but neither claim is correct. Some will claim that before the Cambrian there were only soft-bodied organisms, and soft-bodied organisms do not leave fossils, and that's false. There are plenty of soft-bodied fossils found in many places, many organisms from the Cambrian, and also like the Ediacara, just from the Precambrian fossils, they're soft-bodied, and they are, it's more rare that soft-bodied organisms leave fossils, but it's not true that they never leave, or plenty of soft-bodied fossils found. So that you will hear, and that is not correct. And another claim is that that simply in the Precambrian period it was not, fossils didn't form because it was not a favorable environment for forming fossils. Again, that's not correct. Actually, there are fossils found from the Precambrian that are single cells. You find actually fossils of bacteria in the Precambrian times. You find on a microscope, and you can actually see there are traces of bacteria. And and there are plenty of Precambrian rocks all over the world that should have, if the fossil had been there, they should be there, but they're not there. So that's a Cambrian explosion. And then du gerne over. Du gerne over. Yeah. So here's this Dawkins quote, which we also saw in the film, where he says, "It is as if the species of the Cambrian just were placed there without any evolutionary history." Yeah. So that's a Cambrian explosion. And then we have the problem with that species don't change, and there are thousands of species existing today which have a history on this planet for hundreds of millions of years. And you find in the fossil record, they are the same as we find them today. They have not changed. Then there are some, however, who claim that there are some examples. If you find this admitted, that actually here, this is a good illustration we have here. So here you have these two graphs show the problem with the Cambrian explosion for the theory of evolution. On the top, A shows what Darwin's theory of evolution predicts. You find it's as you go time to the right, you go time, and up. If you go up, you just see greater variety as you go upward. So as with time, variety should simply become greater and greater. Is that clear? And B gives what the fossil record actually shows, that for the greatest part of the Earth's history, the first 3 billion years, actually there's no increase in variety. Then you have the Cambrian, suddenly, in no time, you have the greatest variety, and after that, variety decreases, not increases. This is the actual pattern you find in the fossil.
How come the variety decreases?
Oh, good question, but that is probably partly due to dying out. We have a great variety, and then some die out after species die out. Some film, that Cambrian simply don't, like trilobites don't exist anymore. They died out. They were very numerous. They were like as numerous as snails or spiders are today, but they seem to have been completely extinct.
To illustrate the other part, which also some examples were that there's also species which are very old.
Yeah.
So would that just be like a steady curve on this kind of diagram? Or is it like everything just came to be at that point of time? Or more or less all the species that we know?
Yeah, I mean, I say the peak illustrates that you know, if things are steady, if things are very steady for 3 billion years, and then you can just see suddenly you have a great variety of species, and they remain pretty steady. And every now and then also something new, like mammals are not found in the Cambrian. They're found later. You know, reptiles not found in the Cambrian. And fish are, they would say that, they used to say that fish are not found in the Cambrian, but actually the latest is within the last 20 years they found actually, there were a few fish in the Cambrian actually also. But they only become prominent in the next geological periods. Then what's interesting is that although they will claim that you can find there's no intermediate forms in the fossil record, then you will also find claims that there are examples. And here you see in this Danish text, it's a Danish text from this rethinking Darwin. And so what to think of that? You will find claims that, for example, reptiles becoming birds is documented. You find reptiles that have feathers and are like birds, but they're not birds. They're just developing feathers. At one point, they develop flight. You find some claims about whales evolving. You find claims about horses. You find claims about some fish becoming amphibians, turning into amphibians, something like that, or monkeys into humans. So that you can find examples of, also odd claims like that. But what's interesting is that actually when you examine them, again, it becomes, the evidence is not all that clear, really, that there actually are transitional species here in that case. We can take one example of reptiles becoming birds, and you'll find that story in the in many textbooks of biology, in scientific magazines and so on, and they will claim that they have found reptiles with feathers or proto-feathers. It's not really developed feathers, but just like the beginning stage of feathers. And probably these feathers were not for flight; they were for insulation. So actually, they could keep warm, these reptiles. And then they gradually became developed and became feathers like birds, and birds developed the ability to fly with these feathers. You heard this story before? So